Hello, class. You thought we were done with statistics, but we're not. There's a statistic that we need to talk about before we can move on to trait theories of personality, because a lot of the data that we're going to look at uses this particular statistic. And so there's many reasons why I want to give a little bit of background on this statistic before we move on, because otherwise we cannot evaluate what studies are good, what studies are bad, what personality theories are good, which personality theories are bad. So this is probably going to be the most mathematical lecture that we're going to have, maybe one of the most difficult lectures that we're going to have in this class, but I think it's important for us to get some idea of what's going on with this statistic. I'm going to try to do it without any math. All right, I know that sounds weird. We're going to talk about a statistic conceptually. We're not going to talk about it computationally, because most of the time people do not conduct factor analysis by hand or pen and paper. They use a computer program to do it. It would be too onerous, too complicated to do by hand. So first off, let's talk about why I want to include this in this class, where not a ton of personality classes discuss it in as much detail as I do. So I think it's impossible to understand the scientific and quantitative rigor of some of these trait theories unless we have an understanding of the research methodology and the statistics that underlie those research studies, because otherwise you're going to think, well, Freud said this theory, there's this many personality traits, and this is the reason that personality traits are the way that they are, and the big five theory of personality says there's 5 traits. What's the difference between those two? And if you came to that conclusion, you would be wrong, because there's a whole lot more rigor, there's a whole lot more research that backs up the big 5 theory of personality compared to some other theories of personality. So you would come up with the wrong conclusion of what is a good theory. In fact, if you look at an introduction to psychology textbook, many times they don't say, this is a good theory, this is a bad theory. They just kind of put all the theories in place and say, look at all these different theories, and don't really evaluate which ones have a lot of data to back it up. All right, so you get a false impression of the scientific rigor and the amount of evidence for a personality theory if you don't understand the research methodology and statistics behind it. A good example of this idea, if you don't understand the methodology, if you don't understand the statistics, you come to the wrong conclusion, has to do with theories of intelligence. Unfortunately, in undergraduate psychology programs, we don't do a good job of talking about intelligence for a wide variety of reasons. But if you look back to when you guys had general psychology, maybe a semester ago, maybe a couple of years ago, and you think about what theories of intelligence out there, many times introduction to psychology students, the first theory of intelligence they think of is the Gardner theory of multiple intelligences. This is a theory that states that there are 8 or 9 in the most recent iteration kinds of intelligence, and all of these are uncorrelated with one another. So you can be really people smart and be really, really bad at verbal linguistic intelligence. So there are all these different kinds of intelligence: musical, visual spatial, naturalistic, intrapersonal, interpersonal, bodily kinesthetic, logical, mathematic. So there's all these different kinds of intelligence, and people differ on these, and they're uncorrelated. So you can be good at one and not good at the other. And this is a wonderful theory if we're trying to make people feel good, that you might be bad at this thing, but you're really good at this thing. But there's actually no real evidence to back up this theory. And yet, in Introduction to Psychology textbooks, this theory is talked about all the time. In the textbook I use, this goes on for about 3 or 4 pages about Gardner's theory of multiple intelligences, but it's a crap theory of intelligence. We can compare this to this is called the Cattell-Horn-Carroll model of intelligence. For this theory of intelligence, we have all of these different narrow tasks. So maybe it's a task of geometry, maybe it's a task of word knowledge, and all of these congregate together to form broad traits, so maybe fluid intelligence, crystallized intelligence, mathematical intelligence, memory kind of ability, spatial intelligence, and all these add up to form G, or general intelligence. So this theory states that all measures of human abilities, whether or not it's mathematical, whether or not it's musical intelligence, whether or not it's verbal intelligence, they're all strongly correlated with one another. And there's a lot of data to back this model up. In fact, when we look at all different kinds of intelligence, all measures of human ability, we find that all of them are correlated with one another. If you're good at one kind of intelligence, you're good at all kinds of intelligence, right? And when we present these in an introduction to psychology textbook, you might get the false conclusion that these are equivalent theories of intelligence, when in fact they are not, right? Here is Jack Carroll. Jack Carroll, in 1993, he came out with a book in which he had spent the past 8 or so years of his life analyzing every single study he could get his hands on that looked at human intelligence. And he used this statistical technique, factor analysis, over and over and over again for all these different studies, and he kept finding evidence for this model. So the conclusion that we have here, or the conclusion that I'm trying to say, is that even though in the textbook we might say, hey, look, there's this theory, hey, look, there's this theory, if you don't know the methodology behind the evidence for the theories, you might come to the wrong conclusion that the theories are of equal value, when in fact they are not. So we're going to talk about factor analysis, and we're going to start off by asking the kinds of questions that factor analysis can answer. This is probably the most important slide in this entire lecture. Why would we use factor analysis? So the first question that we can address with factor analysis is, how many factors are there in our data set? All right, we can have a measure of personality, asking many different questions. How many personality traits are there in that measure? All right, are we looking at one major personality trait? Maybe we're just looking at extroversion. Maybe we're looking at 5 different personality traits. How do we come up with this answer? Okay, we can use factor analysis to do this. Now we can use factor analysis for many different types of data. In the field of personality, the factors are personality traits. But if we were doing this same thing with measures of intelligence, we might call them multiple intelligences. We might call them different human abilities, right? Factor is the generic term. It depends on the kind of data that we're looking at. But how many factors, how many personality traits is there in our data set? That is the important question that we're going to try to answer with factor analysis. That's one question. Question 2, all right, what personality test questions do the best job of measuring personality? Okay, what test questions do the best job of measuring which particular personality trait? Now, you might be familiar with some kind of test construction in which we just add up the scores for all the questions that measure the same trait. But you might think that some of these questions do a better job of measuring personality than others. Some of these test questions have more error to them than others. How do we go and find which test questions are the best measures of these personality traits? All right, we can use factor analysis to try to answer this question. All right, the way that we are going to express this in general terms is, how well does each test item, or how well does each test question load onto a particular factor? What that's referring to is, what is the relationship between each of our test questions and the ability and the personality trait? So what's the relationship between our test questions and the personality traits? Is there a strong relationship? Is there a weak relationship with this one particular question? And the last thing, a question we can address with factor analysis is, what are the relationships among our personality traits? Okay, what are the correlations among our factors? Is extroversion correlated with neuroticism? Is conscientiousness related to agreeableness? What's that relationship? Well, it would be hard to look at that if we were just trying to look at the raw scores of our test, but we can use factor analysis to try to get a understanding and an answer to this question. So these are three major questions that we can try to answer using factor analysis here. And again, what I'm doing is I'm trying to explain this at the conceptual level. There's other things we can do with factor analysis. I just want to start off pretty simple for us. All right, so here we have a personality test that I created on a whim when I started teaching this class. I made it kind of dumb to show the purpose of using factor analysis, what's going to happen when we use factor analysis. So it's a 5-point Likert scale, and we have 15 items. I prefer evenings out with my friends compared to evenings spent alone. My room/dorm is more organized than most. I worry a lot about my grades. And you can go through this and see what these items are. Now, the question is, how many personality traits am I measuring? Am I measuring 15 separate personality traits? Am I measuring 2 personality traits? Am I measuring only 1 personality trait? Now, we might have designed the test in mind that it measures 1 trait or 2 traits, but how do we know? How do we have a relatively objective answer for how many personality traits are there in our data set? Let's ask another question. How many personality traits are there, period? Are there 5 major personality traits, 7 major personality traits, 16 major personality traits? We need a way of trying to answer those questions. And one way that we might do that is to ask people a ton of personality questions like this, and then use factor analysis to see how many traits we're looking at. Because it's probably the case that some of these items are correlated with one another. Some of these items are measuring the same thing. Okay, I have a very outgoing personality, question 14, and I prefer evenings out with my friends compared to evenings spent alone. These are probably measuring something similar. But how do we truly know this without looking at the data? So we're going to look at the data to see how many traits it is that we are actually measuring here. Also, which of these test questions does the best job of measuring extroversion? If both of these questions measure extroversion. Is it question 14, I have a very outgoing personality, or I prefer evenings out with my friends compared to evenings spent alone? Which of these does the better job of measuring personality or of measuring extroversion? All right. Okay. Let's talk a little bit more about factor analysis. We can put various kinds of statistics in a few buckets. We can refer to things as univariate statistics. Uni, like unicycle or unibrow, means 1. So univariate statistics are statistics that have 1 dependent measure. Okay, 1 dependent measure. So some examples of univariate statistics, if you have had quantitative methods, or if you've had the statistics class that's taught by the math department, things like analysis of variance, things like t-test, all of these, we're looking at a single dependent measure. Okay, a single dependent measure. Now we might measure that dependent measure multiple times, for instance, in a paired samples t-test, but a single dependent measure. All right, the majority of statistics that you learn when you were in a statistics class come from the univariate variety. All right, many of the times in experimental psychology in particular, we're looking at univariate statistics. All right, there's another type of statistic, bivariate, bi like bicycle. So these are statistics in which we have 2 dependent variables. A good example of this is the Pearson correlation coefficient. All right, we're looking at 2 dependent variables, and as dependent variable 1 goes up, what does the other one do? Does it go up as well? Does it go down? Does it stay the same? What's the relationship between those 2 dependent variables? So that's a bivariate statistic. But what happens when we have 15 personality questions and answers on each of those 15? What happens if we have 164 personality questions? Okay, we've got 164 different dependent variables. How are we going to analyze those? It's quite difficult. But what we can use is something, or a category of statistics known as multivariate statistics. These are statistics that have more than two dependent measures. Great example of this, factor analysis. That's what we are going to be talking about. And that's really what I want you to get from this. Factor analysis is an example of a multivariate statistic. There's others, for instance, multivariate analysis of variance, maybe structural equation modeling. There's many different types of multivariate statistics out there, but they're pretty advanced, and you would not talk about them unless you went off into graduate school. But for our purposes, it's important that we at least have a conceptual understanding of what's going on with factor analysis. All right, there's two flavors of factor analysis. There's exploratory and confirmatory factor analysis. Exploratory factor analysis we use in situations that we don't know how many factors there are. We don't have a particular theory about what we're measuring. We don't know which test questions measure which traits. We don't know how many traits are out there. We want to kind of come up with an answer for this. So exploratory factor analysis is factor analysis where we don't have a theory about what the data is going to look like. Another way of saying this is that exploratory factor analysis is atheoretical. We do not have a theory. All right. Majority of time in this class, we're going to be in exploratory factor analysis land. Okay, we don't know how many personality traits there are. We're going to do the factor analysis to give us an answer. Now, another flavor of factor analysis is confirmatory factor analysis. This is where we have a theory in mind. All right, we have a theory about what's going on with our data set. So we know how many traits. We have a prediction of how many traits there are. We have a prediction of which test items measure each trait. We have an idea of the relationships among our personality traits. So is extroversion related to agreeableness? Is there a relationship there? And with confirmatory factor analysis, we test the fit of our theory. Does our theory do a good job of accounting for the data? If it does a good job, we say that the model fit is good and provides some evidence for our theory. If our model does not fit good, confirmatory factor analysis will help show where that model does not fit well, and we can get a better idea of what this model should look like. All right, so confirmatory factor analysis is factor analysis in which we have a theory. We have an idea of what personality traits we're looking at. All right. Something that's important for us to look at is that factor analysis, what it is going to model, what it's going to look at, is the common variance among all of our test items. Okay, the common variance among all of our questions. There's two important components of this. The first component of this is common. Common means that the items need to be correlated with one another before we are able to pick it up using factor analysis. So let's go back to our questionnaire. I enjoy traveling to new places. Is this measuring a personality trait, or is this measuring some relevant dimension in personality? And the answer is yes, right? It is. But there's no other test question in this questionnaire that looks at how much do you enjoy doing new things. All right. So this test item is not common to anything else. All right. It's not going to be strongly related to anything else, even though it's measuring a real dimension in personality. Number 3, I worry a lot about my grades. It's measuring something like neuroticism. It's not going to be strongly correlated with any of these other test questions because I didn't include another test to measure neuroticism. So there's no common variance here. So factor analysis is not going to pick up, it's not going to say that I have a factor of neuroticism. It's not going to say I have a factor of liking to do new things, even though these are real dimensions in personality, because I don't have multiple questions. All right. So we're looking at common variance with factor analysis, and if a question doesn't have anything common with anything else, it's not going to be picked up by the factor analysis. All right. Part 2, variance. All right, we need to look at some questions that vary. And if a question does not vary, if the answers do not vary, then it's not going to be picked up by factor analysis. Let's look at the test question here. 7, a very, very silly test question. I enjoy kicking babies. Okay. Hopefully, knock on wood, everybody is going to say that they strongly disagree with enjoying kicking babies. All right. Everybody's going to say 1. Does this question measure a real dimension in personality? Maybe, right? You have to be very, 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 very low in agreeableness to say that you enjoy kicking babies, because it's a very, very mean thing to do. All right, but if everybody says 1 right here, if everybody strongly disagrees with I enjoy kicking babies, then this question is going to appear not to be related to anything in personality, because again, there's no variance. Nobody is varying in their score whatsoever. So even though this might measure agreeableness, the same thing that question 10, most people find me agreeable. 11, I like to help others in need. Of these questions seem to measure agreeableness, but these are going to be uncorrelated with I enjoy kicking babies, not because they're not measuring the same thing, but because there's no variation in how people answered 7. All right. All right. So we're going to say 3 steps to factor analysis. Now, again, when you go off to graduate school, if you go off to graduate school, it's going to be a little bit more complicated. But let's say that there's 3 steps. All right. Step 1 for us is what we're going to do is we're going to collect every single correlation of every item in our test to every other item in our test. All right. So we go to our test. What's the correlation between question 1 and question 2? What's the correlation between question 1 and question 3? 1 and 4, 1 and 5, 1 and 6, and then 2 and 3, 2 and 4, 2 and all those correlations. All right, which is going to be a crap ton of correlations. All right, it's going to be a massive amount of correlations, and this is only for a 15-item personality test. Think about if you had a 164-item personality test or a 256-item personality test. It's going to be a crap ton of correlation coefficients. But we need to look at all of those correlation coefficients. This is just a reminder to us about what a Pearson correlation coefficient is looking like. If scores on question 1 increase and then scores on question 2 increase, then we have a positive relationship there. If there's no relationship whatsoever, then we have a correlation close to 0. The stronger the correlation is, the more it's going to be close to either -1 or +1. Weaker correlations are closer to 0. Nothing new there. We covered that in module 3. All right, so we're going to put all of these correlations in what's known as a correlation matrix, and this is going to look like a hot mess. Okay, and here it is kind of a hot mess, but we look at the correlations between question 1 to questions 1 through 15. Okay, we have every single correlation on this correlation matrix, and we're going to use this to do factor analysis. Now, if we want to see, let's just say, what's the correlation between question 2 and question 7? I'm going to go here to question 2, go to question 7, and I see that it's 0. Now, 7 wasn't good. Let's say 2 to 8. 2, 8, the correlation is 0.45. But every correlation is in here twice. Okay, I could go 2 to 8, or I could also go 2, go down to 8, and I see that it's 0.45. And in both situations, it is exactly the same, as it should be. So this follows a important principle here for correlation matrices. If the matrix is symmetrical about its major diagonal, all right, here we have the major diagonal in the correlation matrix, and every correlation on either side of the major diagonal, okay, it's going to appear twice. So correlation between question 1 and question 2 is 0.05. We see it on either side here. All right, so each correlation appears twice, and the correlation matrix is symmetrical. All right, if we were to take the correlation matrix and fold it over, all of the numbers would match up. All right, the correlation that's furthest down here is negative 0.09. We go to the correlation over here, it's negative 0.09. All right, so the correlation matrix is symmetrical about its major diagonal. That's important property number one. Important property number two, on the major diagonal, we always have ones. Okay, the correlation with anything in itself, okay, is a perfect positive correlation. All right, if person one scored a 5 on question one, they also scored a 5 on question one. No duh, it's the same thing. So there's going to be a perfect correlation between the question and itself. So there's going to be ones on the major diagonal. That's important property number two of a correlation matrix. Okay, so there we go. Some important qualities of a correlation matrix. Now, I said that there's 3 steps to doing factor analysis. Step one, we get our correlation matrix. We need to calculate all these correlation coefficients and put them all in this matrix. Okay, we've done step one. Step two, I'm not going to show you how to do because it's mathematical and you don't need to know that. Okay, I'm going to wave my hands and I'm going to say magic happens, and then we're going to get the results of our factor analysis. But I want to show you, if you have a good eye, you can kind of see what's going on with the factor analysis before we do the magic, before we do the math. All right, so let's look a little bit about some interesting things that are happening here. First of all, look what's happening with question 7. Question 7 is uncorrelated with everything else except for itself. Why is this the case? Why is this the case? Well, it turns out that question 7 was I enjoy kicking babies. If everybody puts 1, okay, it's going to be uncorrelated with everything else because there's no variability there. Okay, so we can see that with our correlation matrix that question 7 didn't work out. That it's not going to be correlated with anything because there's no variability there. All right. We see that there's some questions that tend to be highly correlated with one another, but uncorrelated with everything else. This is evidence that we have a true factor here, that we have evidence of a personality trait. We see questions 1, 4, 12, and 14 are all strongly related to one another, but uncorrelated with everything else. Let's look at these questions. 1, 4, 12, and 14. 1, I prefer evenings out with my friends compared to evenings spent alone. 4, I'm often considered the life of the party. 12, in crowds of people I rarely talk. And 14, I have a very outgoing personality. Now, factor analysis does not tell you the names of what these personality traits are. It's up to you as the researcher. So what do you think that we have here? It seems that we're measuring extroversion. Right? It seems to be a trait measuring extroversion. All right. Evidence of a factor. So it seems like when we conduct our factor analysis, we're going to find evidence of a factor for extroversion. Also interesting here, notice that for question 12, all the correlations are negative as opposed to positive. Everywhere else, the correlations are positive, but whenever question 12 is correlated with these, it's correlated negatively. Why is that the case? Well, question 12, the higher your score, going from 1, strongly disagree, to 5, strongly agree, the more introverted you are as opposed to extroverted. So the sign of this correlation, the negative sign, indicates that this is a reverse-coded item. Right? It still is going to load, still going to be related to extroversion, even though we have a negative relationship here. All right. Here we see question 5, 2, 8, and 9. All these questions are highly correlated with one another, and they're uncorrelated with everything else. So these questions seem to go together. Probably evidence of a factor, probably evidence that we have a personality trait going on here. 2, 5, 8, and 9. 2, my room/dorm is more organized than most. 5, I'm often considered diligent. All right, 8, I'm always on time to class and other events. 9, I prefer planned events as opposed to spontaneous events. Probably we're measuring something like organization. Maybe we might call it conscientiousness if we know a little bit about the Big Five theory of personality. So we seem to be measuring conscientiousness here. All right, so that's important. Okay, so it makes sense that these items go together. Seems that we've got evidence of a personality trait, a factor here in terms of factor analysis. Last one, we have question 6, question 10, question 11, and question 13. How do we find these bolded answers? Well, I'm just eyeballing it. Factor analysis will give us a better answer for what questions go together. But I'm kind of eyeballing it to show you that even beforehand, we might have some evidence that something's going on here, and we might make predictions about what factor analysis is going to tell us. So again, questions 6, 10, 11, and 13 seem to go together. 6, I'm easy to get along with. 10, most people find me agreeable. 11, I like to help others in need. 13, I typically do as I am told. So this seems to be something like agreeableness, okay? How nice you are, okay? How mellow you are. You could call it by whatever name you want to. Factor analysis does not give you the name. But we are predicting that we're going to have 3 factors here: extroversion, agreeableness, conscientiousness. That seems to be what we're finding in this personality test, just by eyeballing it. But what does the data actually tell us? All right, we don't know that. We need to do the factor analysis to find it out. Okay, so we've got this huge correlation matrix, and it's ugly as all get out. We need a way to simplify it. So we're going to use some matrix math. By the way, random tangent. Way back in the day when I was in Algebra 2, we did some matrix math, and you've probably done something similar where you had to calculate the inverse of matrices and the determinants of matrices. And I remember vividly raising my hand in that class and being like, why do we need to know this? You know, that annoying question that people tend to ask in math. And I remember my teacher saying, oh, well, I don't know. Well, they never say that. They say, you're going to use this in math later on. And I was like, okay. And then we never got to it. We never got to it in other classes in high school. We never got it into undergraduate, and we didn't get it to the early classes in graduate school. It wasn't until like later in graduate school that that matrix math ever came back into play. And I was like, I wish my teacher had known what this was about, because this stuff is kind of cool if you know what the matrix operations are good for. All right, so sorry, random tangent. You'd be surprised when math comes back into play and how useful it can be later on. Okay, so we need to do something to simplify this matrix of items. So we're going to use some matrix math. It's called eigenvalue eigenvector decomposition. You don't need to know that. That sounds really highfalutin, and you can use that in your everyday language if you really want to sound smart, but you don't need to know that. Just know that we're simplifying this matrix. We're combining this, we're taking this huge correlation matrix and we're taking it and we're breaking it down into 3 smaller matrices. And if you were to multiply these 3 small matrices together, it would get you that big one. So all we're doing is just simplifying this huge correlation matrix. But with these 3 different matrices that we're going to get in simplifying it, we are going to be able to answer one of our 3 different questions that we had at the very beginning of this lecture. Okay, how many personality traits there are? Our first matrix, which we were going to call our matrix of factors, tells us the answer to that. How many personality traits there are? Matrix number 2, which personality traits or which items correlate with which personality traits? Okay, our matrix of factor loadings is going to tell us that. Okay, which test item does the best job of measuring extroversion? Which test item does the best job of measuring agreeableness? We are going to be able to find that out. All right, third matrix is our matrix of factor correlations. This is going to tell us what's the relationship between extroversion and agreeableness. What are the relationships among our personality traits? Our matrix of factor correlations can tell us this. All right, so we've got three matrices. We're going to analyze those, and they're going to help give us our answers. So 3 steps of factor analysis, at least for us in this class. Get correlation matrix. How do we do that? We find every correlation between every item in our personality test and put it in a symmetrical matrix. 2, magic. We're going to do some math. You don't need to know that. Just know it's magic. 3, we have our 3 matrices, and we're going to interpret those 3 matrices to answer our 3 major questions. How many personality traits there are, which test questions measure which personality traits, how good do those test questions measure those personality traits, and 3, what are the correlations among our personality traits. All right, so the matrix of factors is going to tell us how many factors there are in our data. In the field of personality, this would be personality traits. Our matrix of factor loadings is going to tell us how well each of the questions loads onto a particular factor. That's the phraseology. Phraseology, I'm just making up words here. That's the phrasing of factor analysis. How well a test question loads onto a factor. That's essentially just asking what's the relationship between the test question and the personality trait. Okay, nothing fancy there. Like making up words like phraseology. What the heck am I thinking? I don't know. All right. The matrix of factor correlations is going to tell us how well the factors correlate with one another. What's the relationship between extroversion and agreeableness? What's the relationship between neuroticism and conscientiousness? What are these higher order relationships among our personality traits? The matrix of factor correlations is going to tell us this. All right. So here's our matrix of factors, which is less of a matrix and more of just a column of numbers. All right, and this ellipsis down here, there's going to be however many questions that we have minus 1 positions in this column. So there would be 14 different rows to this column as we go down. What we do is whatever is our first factor, okay, accounts for a certain percentage of all the variation in all of the items that we have. We pick a particular cutoff point, and we accept however many factors there are that are above that cutoff point. The cutoff point that we typically use for factor analysis is 1. So however many of these numbers are above 1 is the number of traits that we have. So 4 is above 1, 3 is above 1, 2.03 is above 1. It seems that we have 3 personality traits, which is what we predicted in the beginning, so good job us. Okay, so this is telling us that we have 3 personality traits. That's what we predicted, so good job. Another thing that we can do here is we can estimate how important each of these factors are. So whatever factor 1 is, we could take that 4.32, and since there's 15 items, we can take that 4.32 and divide that by 15. And this is going to give us how much variation in all of the test items does factor 1 account for. So 28.8% of the variation, the common variation in all of these test items, the reason why all of these test items are correlated together, can be explained by factor 1, whatever factor 1 is. We can do something similar here for factors 2 and 3. So factors 2, 3.23, we had 15 test questions, we're divided by 15. This gives us 21.5%. So that means that factor 2, whatever it is, accounts for 21.5% of all of the relationships among all of the test items. Okay, the cutoff point that we typically use is we are going to accept however many numbers we have that are above 1. That's how many factors that we have in our data set. Okay. Here we have our matrix of factor loadings. Here we have factor 1, factor 2, factor 3. We don't know what those names are yet, but we're going to have names here soon. We're going to come up with those on our own. And we see which of these test items does the best job of measuring factor 1. We see that the loadings that are the highest here are 0.73, 0.60, negative 0.45, and 0.63. Okay. The way that we're going to come up with the name of this is we're going to look at questions 1, 4, 12, and 14. 1, 4, 12, and 14. Lo and behold, it's extroversion, or something that we could call extroversion, or how outgoing someone is, or we could make up our own word. Okay. We can call these factors whatever we want to, but it seems like something like extroversion. Other theorists have called it extroversion, so let's just go with that. Which test item does the best job of measuring extroversion? Seems to be 1. 1 has the strongest relationship here, followed by 14, followed by 4, followed by 12. Okay, so we can tell how well each of these items measures our personality traits. Okay, so factor 1 we're going to call extroversion. Question 1 seems to be doing the best job, according to the study that we've conducted. Factor 2, we have 2, 5, 8, and 9, where 8 seems to be the best predictor of whatever this factor is measuring. Can we look at this? So my dorm room is more organized than most. I am always on time to class. I'm often considered diligent. I prefer planned. This seems to be how organized someone is. And the last one, where it seems that 6 is the best predictor here. 6, 10, 11, and 13. I'm just highlighting ones that are pretty large compared to everything else to give us some indication here of what questions dominate the measurement of this particular factor. In this case, this tends to be how agreeable someone is. I'm easy to get along with. Okay. I like to help others in need. Most people find me agreeable. I typically do as I'm told. All those tend to go together. All right. So we find 3 factors. We see which test questions measure those factors and which test questions do the best job of measuring those factors or personality traits. The last matrix we get is our matrix of factor correlations. And we can see that the relationship between factor 1 and factor 2, the correlation between extroversion and conscientiousness, relatively low here. The correlation between extroversion and agreeableness, also very low. So there tends not to be at least for the personality test that I created, very strong relationship among these 3 different personality traits. But we can answer a lot of cool questions by just giving a personality test out and doing factor analysis. All right, we can come up with how many personality traits there tends to be in our particular data set. If there were strong correlations here among all of our factors, one thing that we can do is we can then factor analyze the matrix of factor correlations. So we can do factor analysis, get the correlations among the factors, then do another factor analysis, then maybe do another factor analysis, and we can get higher order factors. All right, this is how, for instance, in the Cattell-Horn-Carroll model of intelligence, we start off with all of the tests, and then we get narrow traits, so maybe something like visual intelligence, maybe something like mathematical intelligence, and we factor analyze those correlations to get G, general intelligence. We can do the same thing with personality. Okay, maybe there are, if we look at personality traits, maybe we might get some narrow traits, but those narrow traits are correlated with one another. So we factor analyze the factor correlations and get broader traits. And then we take those broader traits and we can factor analyze them. So we can come up with a hierarchical model of some of these personality traits to explain all of their relationships to one another. Okay. Again, somewhat difficult lecture, but I want you guys to go through this lecture at least another time. Again, we're trying to conceptually understand why we're doing factor analysis. The math is not important, okay? I don't want you to know anything really about the math, but the kind of questions that we can answer with factor analysis and why we're conducting it, that's what I want you to get from this lecture, all right? Good luck, and I will talk with you guys later. Bye-bye.